So here we have this funky little piecewise function, and it says our function is going to be this parabola, except, hey, wait a second, no. When x is 2, no, we're not going to let it be that parabola. When x is 2, we're going to make this thing be -5 instead. Fine. So they graph it for us, happy. And all we're doing is wondering when the limit goes, when x goes to 2. So what I do is I just say, okay, when x is 2, what's the y value? Or what is, for the limit, what does the y value want to be, right? Because you can see here that f of 2 is actually -5, right? When we plug in 2, we get -5. But that's not what the y value wants to be. When x approaches 2, the y value is approaching this point here. It wants to be a -2. And that's what this is. So this function is clearly not continuous. We'll talk about that in another video, but so it's not going to be just that -5, but the limit, that's the point that we're approaching, and that's that guy. Same thing with this one here. When x goes to -2, the function's not defined, but what it wants to be is 4. So we're allowed to say that this actually equals 4 because the y value is 4. Excellent. Later on we get to these guys, and we could do this graphically. I've got whole videos on how to graph these things. And the first thing you would do if we had to graph it for ourselves is try to factor that top. Maybe the bottom cancels. So you would get, lost the limit. Limit as x goes to 3 of x minus 4. And so now you can just put in the -1 and kind of doing it algebraically, and that's that. Because basically what this graph is the line of x minus 4. So you could graph x minus 4, there's your y-intercept, up 1 over 1, up 1 over 1, up 1 over 1. And it basically is that line if you were to graph it, except when x is 3, you've got this darn hole. So when x is 3, the thing is undefined. So we have to erase that point, put in a hole, and that's what the graph would look like, is just the graph of that is just a line with a hole in it. And so we can see that when x goes to 3, the y value wants to be -1, even though the function's not defined there. We can see where it approaches, what that limit's supposed to be. So we got that guy there. And that's our first tool. Like if you just tried direct evaluation like we did in one of our first videos, it wouldn't work so well. You would get -3 plus 3. I mean, you try it first if you're doing this, and you get 0 over 0. And 0 over 0 is what's called an indeterminate form, and this is not happy for us. We don't know what this is. So first line of attack is try to maybe factor it. So this would be x plus 3, x minus 1, and those guys cancel. So we get 1 over x minus 1. So now that we've simplified it, it's okay to reevaluate this limit. -3 minus 1 is 1 over -4. And that's what our limit's going to be. So again, I went to the algebra way, but if you wanted to do it graphically, this big function here did simplify to this function here. Just when x is -3, it's got a hole in it. So this function here is a rational function. It would have a vertical asymptote at x is 1 and a horizontal asymptote when x is 0. And you could just maybe plug in some points just to get kind of a sketch. And then I'm kind of concerned when x is -3. So when x is -3, 1 over -3 minus 1 is -1/4. So yeah, I can kind of see it here. My graph is not perfect, but like right there, when x is -3, the y value wants to be 1/4, but by the original function standards, it wasn't defined there. I had this, when x is -3, that blows up, and that's not part of the domain. But I can see that it approaches that. So I will stop there for the moment.